Hello, everyone. Welcome to the EDB webinar Tips for Maximizing Postgres Performance. My name is Joanne Huang, and I'm the Marketing Director for APJ at EDB, and I'm your host today. So before we start, there's a few housekeeping items. This session will be recorded, and we will share the recording with the registrants after the event. And secondly, we have Q&A sessions in the end of the event, so feel free to submit your questions during the Q&A box. So we're joined today by Vibhor Kumar, who is our Vice President of Performance Engineering and Architecture team at EDB. Vibhor has more than 15 years of experience helping large organizations adopting and scaling their open source strategy through Postgres by migrating from proprietary database or developing new applications in on-prem microservices or the cloud. In his current role, Vibhor and his team have published multiple scripts and tools to tune Postgres and make deployment effortless and at scale. In addition, they have published blogs, white papers, and benchmarks to showcase Postgres as a powerful technology for digital transformation. Okay, so let me hand it over to Vibhor for today's session.
Thank you, Joanne. Thank you for the wonderful introduction. So let's look at exactly Postgres, right? We talk about Postgres, and this is my hero slide. Here we talk about why Postgres is a clear winner in the database game. These are some important surveys. It's not us, it's the surveys done by the third party, which shows that why the PostgreSQL is so popular database and is a loved database for the developers. So Stack Overflow developer survey, which was done in 2022, in this year, we found that PostgreSQL is the most loved database. And it's also most popular database, which you can see it here. In the same way, if we look at the Cloud Native Computation Foundation, CNCFT technology, you will see that PostgreSQL is the most used database in the cloud native environment, mainly Kubernetes, or if you think about containers. So same thing, you can look at the top technology running on Docker. You will see Postgres is one of the technology getting used. And if you see all these platforms, right, these are really well-known platforms and popular among the developers because it gives the agility for developers to write applications. They can easily release a new version of the application or new version of the code using Kubernetes or using the containers, and they can quickly be in production. And Postgres is really there with you with the developers, and they're leveraging Postgres to write new application, innovating with the new application development with PostgreSQL. Now, with PostgreSQL, let me take a little bit moment to introduce about the EDB and tell you about EDB, who we are, what we do. We are the database fanatics who really care about PostgreSQL. We are the largest dedicated PostgreSQL company, have many developers working with community, defining the roadmap, adding capabilities, understanding, of course, based on the use cases, adding more and more features which developers can leverage in innovating the application, developing new applications, or maybe work towards innovations. We are major PostgreSQL community developers working with the community. We have leadership like Dave Page, Bruce Momjiam, who are part of the PostgreSQL core team. We actually founded in 2004 and went out of the stealth mode in 2006. Over the years, we have added so many capabilities like hot, which is a heap-only tuple capability in the PostgreSQL. We also worked on adding multi-line views, parallel query capability, JIT compilation, and later on with the acquisition of a second quadrant, which was part of the EDB, and later on became a different company. We acquired that company in 2021. Our contribution is pretty much visible that we have added more features in the PostgreSQL community. So this is all about EDB. We are really helping community. We actually partner with the community, partner with our customers to add the capabilities, features in a true fashion. Now, so with this introduction, let's get into more detail about tuning or tips for maximizing the performance of Postgres. So when we talk about Postgres, the hardware is very, very important piece. So I'll start with the bare metal first, exactly what you need to look at, what are the important components, how those components are important for the performance of Postgres. One is of course, CPU. In bare metal, CPU is very, very important. If you have more CPUs, then you actually helping Postgres to perform better. As you know that Postgres is a process-based, has Postgres a process-based architecture. So whenever you make a connection to a database, whenever you open a session, there'll be a new process created behind the scene, and that process will be serving all the requests. And CPU plays a key role here. So if you have more CPUs, then all these processes, all these sessions will be able to leverage those CPUs. But with CPUs, there's a very important piece called caches, right? L1, L2 cache are very much close to the CPUs, and it gets used only by the CPUs. But there's another cache called L3 cache. This L3 cache is very important because L3 cache helps in putting those data and making it more accessible to the CPU, because L3 cache is for the user data. So that's also a very, very important piece. So when you're considering a CPU, you always think about using the fastest CPU for the Postgres and try to get more L3 cache for the data to get a better performance out of Postgres. Next is disk, right? Disk is very, very important too, because all the data is stored on the disk. If you have a fastest disk, you get a better performance. Whenever you're reading a data, writing a data, disk performance really impacts the performance of Postgres, and directly also impacting the performance of your application or the users who are really accessing the information through the application, right? So based on the read intensive and write intensive, based on your workload, right, you can choose a better disk or better performance disk. Nowadays, people are mainly going with the SSD disk. Those disks are fast and can give you better performance, right? Now with this, with of course application workload, which deciding the disk, right? You would also look at the RAID. RAID is also very, very important. So there are two important part of the Postgres. One is called transaction log, which is called wall file, and there is an actual data directory where PostgreSQL keep the actual data or user data. So those two are the important mount points, and for those important directories, you would like to provide a dedicated disks, and those disks, again, you can choose based on your workload. You can go with the RAID 1 or RAID 1.0. As you can see here in this slide, you will see I've put some snapshot of the benchmark which we did for the RAID. There are many different possibilities of RAID. You can use it. You can use Mirror. You can use RAID Z1, Z2, RAID 1.0, and Stripe. And you can clearly see that RAID 1.0 is really performant most of the time when you go with the data and the wall. There is another part called table spaces. Table spaces is very, very useful for multi-purpose. Like you can actually, if you have a workload defined in your system, if you are keeping some archive data, and let's say if you have a 10% of data, which is hot data, which are getting access often, and there's a one read-only data too, right? So based on the category of a data, if you have, you can divide those tables with among different table spaces, and these table spaces can be utilized, can be used for utilizing a different kind of disks, right? Like for example, if you have a hot data, you would like to keep it on fastest disk. If you have a read-only data, which requires more cache, you can go with RAID 1.0 or maybe add more cache around it. If you have only archive data, you can put that to a cheaper disk. So this way you can distribute the data on a disks based on the utilization of those data by the application. So disk is very, very important. And we always recommend to go with the fastest disk and RAID 1.0 at least for data on the wall. The other part component is called RAM, random access memory, right? This memory is very, very important. If you have more memory allocated to the Postgres, is good, because this way you will have more data cached into the memory and there will be less IO activity and your system will be performing faster. The application will get better performance out of the system. So again, nowadays RAM is very cheapest component. So we always recommend to go as big as you can, buy as much as RAM if you want, based on the workload, definitely, right? How much data you want to cache in. Let's say 20% of your data is a hot data, which you want to cache into the memory, go with that size, right? If you allocate more and more space, more and more RAM, it would also help you to reduce the page in, page out, which is going to happen based on the workload on the system. And again, this is directly impacting the performance of your application, and of course, going to give you better performance for the Postgres. And they when we look at the cache, as I mentioned, less IO. Nowadays, there's also one more concept called hot swap RAM, right? I mean, you can go with the less RAM, and based on the workload or based on the increase of the users on the system, you can add more RAMs later. But hot swap sometimes becomes more expensive. The reason is that when you are swapping the RAM, when you're adding the RAM, that time you actually double the RAM on the system, right? Then in that case, you have to run with that amount of a RAM on the system, and becomes expensive from the cost perspective. So RAM is the other piece. The most other important element when you're thinking about bare metal or hardware design is the network, right? Because network between the application and your system where your database is running. And sometimes if you're using the network storage, that network bandwidth also is very, very important. Because if your network is slow, right? If you have a fastest system, but if your network is slow, you will get a very bad performance. So always keep in mind, you should always would like to have a better network bandwidth between your application, application and the database system. Plus, if you're using the shared storage like SAN storage, anything, try to get more bandwidth for writing to the SAN storage through that system. So if you get a faster network, better performance. Network also plays a key role in high availability too. So if you have a replica, and replica if you're using for read scalability, also for the high availability, having a better network bandwidth will of course reduce the latency of the data transfer, and your data will be highly available with the higher network. So that's all about the hardware if you're going with the bare metal. But nowadays, people are moving away from the on-prem or bare metal system to the cloud, right? Where mostly people are using the virtual machines. And that's why it's very, very important. When you're choosing a virtual machine, you should consider certain factors, right? For your workload, for your application, or how you would like to get a performance from the Postgres, right? So let's look at exactly what are the important components which you should consider when you're choosing a virtual machines. So before going to the virtual machine, let's understand the virtualization, right? There are two different kinds of a virtualization. One is called para-virtualization, and second is called the full virtualization. In para-virtualization, actually, there are certain components are not really virtualized. In full virtualization, everything is virtualized. In para-virtualization, what happens, like you can virtualize CPUs, but disk and all those things, you can keep it simple. Like the best example I can give you, queuing systems, which people used to use in the past. But if you think about disks, this is pretty much available. There is no virtualization created, but the processes for those, they are specific. CPUs are pretty much pinned, or CPU cycles are allocated to those processes to work on it. Those kind of machines were pretty much common in the old days. I think now people are going with the full virtualization, which means everything is virtualized, including the disk, which the EBS volume, for example, which you see on AWS side, that's also kind of virtualized. There are IOPS allocated to the virtual machines based on whatever you bought. So those are full virtualization. In that case, again, you need to think about a couple of things. One is that CPUs, which are, of course, virtual CPUs, which are locating CPU cycles, speed of those virtual CPUs allocated to your virtual machine, right? IOPS are defined for your virtual machine, right? Because there are two different kind of IOPS, I would say. One is that directly attached to the virtual machine, and second is the extra volume which you can buy and attach to the system. You would like to Generally, I always recommend people to go with the dedicated virtual machine, dedicated cycles for the Postgres, because if you don't have a dedicated hardware, and if you have virtualized everything, it may be possible that there will be some noisy neighbors which might be eating away the CPUs and starving your Postgres instance to perform better. So we always recommend to pin the CPUs and give a dedicated IOPS to the Postgres so that you can get a better performance out of it. The other piece which you would like to consider for the virtualization, of course, number of cores which you want to allocate based on number of virtual machines you want to define on your system, amount of RAM you want to define, number of virtual machine you want to execute, and of course, allocate those RAM properly. And again, the other key part is the network throughput for sure, because to allocate such a huge volume of disk space, right? You would like to use a shared storage, and having a network connectivity between proper network bandwidth between the shared storage and the virtual machines are very, very important. There's also important piece called NUMA pinning. NUMA pinning is actually, you can think about if you have multiple NUMA nodes through which you are clustering all the CPUs and locating or providing those CPUs to the users to the virtual environment. You would like to make sure that the CPUs which you have allocated for the Postgres are properly pinned. Because if you don't do that, if suppose due to the virtualization or let's say hypervisor wants to optimize the CPUs across multiple virtual machines, sometimes it actually try to transition some of the CPUs to the other NUMA node. So during that transition process, right, it actually affects the performance of Postgres because the transition requires the process transition to the other CPUs on the other NUMA node, plus data which has to transfer from the one NUMA node to another NUMA node, which becomes very expensive. That's why we always recommend to pin those CPUs on the NUMA, specific NUMA node with the CPUs which you're using for the Postgres. Other pieces, as I mentioned, disk, right? Pre-allocated disks are very, very important because those pre-allocated disks with the high ops would help you with the virtual machines. You can go with the rate on the virtual environment, virtualization or in a virtual environment using the MD rate. But based on our performance benchmark, we haven't found much benefits there. You could use it, but I mean, we don't recommend to use that kind of a RAID in the virtual environment. We always recommend to use a dedicated IOPS or provision IOPS for your disks, which you are going to use for storing the data of the Postgres, or which you can use for the wall that's right ahead log file of the Postgres. These dedicated IOPS definitely going to give a better performance because it's increased the IO operations, allows you more IO operations through Postgres. And you can choose the IOPS and pre-allocated disk size based on the workload. Now, those are the some important components for your virtual environment, for your bare metal. And again, if you want to categorize, you can categorize in terms of CPU, RAM, and disk, right? And our disk is directly related to the IOPS, amount of IOPS you want to allocate to the Postgres. Now, there are other parameters which you would like to tune, like operating system, to get a better performance out of it, because Postgres highly rely on the operating system for certain activities, right? And that's why if you tune the operating system, you automatically see the better performance out of the Postgres. That is, the tuning the operating system reflects the performance of the PostgreSQL. Nowadays, if you go with the modern operating systems like Red Hat, RHEL 8, or Rocky Linux, or any other operating system, you will see or adaptive system tuning daemon process is pretty much available through the operating system. These dynamic adaptive system tuning process or daemon helps in defining the different profiles based on the workload, and based on that profile, the system will be automatically tuned for your application. Here's one example which you can see here, where you can include some important components, like for example, a governor equals to performance, or energy performance bias equals to performance. These two are the key important parameters, right? Because if you go energy preference bias equals to power save, in that case, the CPU cycle will be slower for the Postgres, and it will highly impact on the performance of the Postgres. We want CPUs to be always available, up and running, because you get better performance out of it. Um, and that's why you need to make sure the energy performance bias equals to performance for the PostgreSQL. Read ahead is another important parameter, which actually helps the operating system read the blocks out of the system. We recommend to set it to the 4 kilobytes. As you know, that Postgres actually use 8 kilobytes of the pages. 4 kilobytes actually helps in reading those pages quickly, and the read operation becomes 2 times instead of going like a 4 times, which is the default setting of the operating system. In the same way, we have a different parameters like swappiness, overcommit kilobytes, overcommit memory, right? These are some standard parameters we always recommend to set with the PostgreSQL. Key important other two key parameters are dirty bytes and dirty background bytes, right? These parameters is important for the PD flush daemon to really flush all the dirty buffers of the OS cache to the disk, right? If it is huge, if you have a huge value for it, or by default, operating system uses the ratios, which may be optimal for the small size of the RAM or small size of the memory allocated to the system. But if you have a huge memory, right, or multi-gigabytes memory, then in that case, those ratios may not be optimal for the Postgres performance. In most of the cases, we have found that 1 gigabyte of the memory is enough for the dirty byte setting, right? If 1 gigabytes are dirty and PD flush daemon writes those back to a disk, then you get a better performance and you will have a spread IO of the system. We always recommend to disable the transparent huge pages, because as per our testing and benchmark, we have found that transparent huge pages really impact on the performance of the Postgres. And again, this is one example. You can see how you can create one tuned.conf file for EDB, and how you can enable this tune using tuned profile. Again, it based on the tuned administrator command called tuned ADM, where you can pass the specific profile which you have created for your system. The other important parameter is called huge pages. Huge pages is very important element nowadays, because you have to allocate few huge pages, and this way you can reduce the size of table to huge pages and can increase the performance out of the operating system, plus management of those huge pages too. PostgreSQL definitely can utilize this huge pages. It helps the Postgres to cache more data into the RAM. Default is 4 kilobyte, but based on the benchmark which we did, we found that Postgres can perform better with the 1 gigabytes too. So you can go with the huge pages, and you can set bigger pages for the PostgreSQL. But again, when you set this parameter, it requires a restart of the PostgreSQL plus a restart of the operating system. The other part is the file system. This file system, which you can use for your data directory, for your WAL file. When you're mounting the file system or mounting a specific disk to the operating system, we always recommend to use no time, because because PostgreSQL doesn't really rely on the operating system access time, and it just only adds the extra CPU cycle on the from the processing purpose, right? Disabling this helps in saving the CPU cycles, and those CPU cycles can be used by the PostgreSQL. And you will see really, I would say, depending on the size of a database, you will see the impact on the performance when you see no time. With no time, you get a better performance out of the operating system, and it directly reflects in the performance of the PostgreSQL. Other part is the selecting a right file system. We always recommend to go with the XFS file system. There are other file systems available for the users like ZFS, BTRFS. BTRFS file system is still okay, but we found that in most of the workload, like mostly PG bench kind of workload or OLTP workload, we found that ext4 XFS is the best file system for the PostgreSQL. As you can see in this chart, right, XFS in most of the cases performed better than any other file system. We don't recommend BTRFS because it's not really matured yet, but going with the XFS, you will definitely get a better performance with PostgreSQL. Now, those were really about operating system tuning, about hardware, selecting the right hardware for the PostgreSQL. Now, with all those tuning, with all those steps, right, you will definitely help in boosting the performance of Postgres. But there are some parameters on which PostgreSQL relies to give you the throughput or to give you the better throughput based on the changes which you pass on to the PostgreSQL. So let's discuss about these important parameters. And these parameters definitely, tuning these parameters would really help you getting a maximum performance out of the Postgres. So one of the first parameters is called shared buffer, which we will be covering later. But let me give you one more important information that the default parameters which comes with the PostgreSQL is in general optimized for the systems which has low memory or low disk space. But those may not be true when you go into the production. And if you have a workload which requires more memory, more CPUs, and if your application is opening more sessions, then tuning these parameters would be very, very helpful for your workload. Sub parameters you can change on the fly and reload into the system. Some parameters you would require restart. That's why when you are deploying Postgres, you would like to first test those parameter settings based on your workload in your test environment or maybe pre-production environment. And when you go into the production, you can simply create the profile of the PostgreSQL conf file which you want to push with your deployment. So let's take a look at those parameters. The first parameters is max connections, right? Max connections is, as it says, that number of connections which you can establish on PostgreSQL based on your workload. Let's say if you have many users connecting to your application, for each user you want to create a new session, you can create a connection with the Postgres, right? But max connection is the performance. I mean, when you are defining this max connection value, there are two factors you have to consider. One is that how many connections you need for your application to serve the request from the users. Again, depends on the workload. And second, how many CPUs are available on the system, right? If you have less CPUs and more connections, in that case, the system will not perform well, because CPU cycles will be distributed among those processes, the processes which are supporting those connections based on the application request. We generally recommend to keep a ratio of a 2:1 or 4:1 based on the number of cores you have, because we have seen better performance with those. But let's say if you have a huge requirement of the connection, then in that case, we would recommend you to go with the connection poolers. Connection poolers like PG bouncers or PG pool. PG bouncer is a better connection pooler because it can spawn multiple threads for your user request and can use limited number of connections which are established to the Postgres. We have also seen a couple of more items, like if you go beyond 1,000 or beyond 500 connection or certain CPU systems, right, you may not get a better performance because of the context switching happening with the processes, and also the way Postgres actually maintain the connection information on in the shared memory structure. So we always recommend to balance the processes versus number of CPUs available on the system. And B, if you require more connections, we highly recommend you to go with the connection poolers. You can use either application level connection poolers. With that, you can also use connection poolers like PG Bouncer, which are popular connection poolers with the Postgres. The other parameters, which is like shared buffers, right? It's a very important parameter for the better performance, right? depending on amount of memory available on your system, right? Or depending on the workload, you can actually increase the shared buffers. Um, Again, as I told you, it all depends on the workload. We did a couple of we actually performed benchmarks around the shared buffer, and based on the benchmark or based on the benchmark, the data which we have seen, we saw a specific pattern around the shared buffers. Again, it also directly proportional to the workload of the application. But for the mostly for the OLTP workload, we had seen that that if you have a huge amount of a memory on the system, and your let's say 1/4 of memory is like 75 gigabytes, you may not get a better performance with increasing to that level of shared buffer. We have seen like 65 gigabytes or 64 gigabytes is an optimal performance, optimal shared buffer size for the OLTP kind of a workload. And again, based on the pattern which we had seen on the benchmark data, we came up with this specific algorithm where base equals to, you can start with the 1/4 of the RAM. And if your size of the RAM is less than 3 gigabyte, you can get with a base of a base of the 0.5 factor multiplication, and you will get a result of the amount of memory you want to set. So this is you can see a zero algorithm which you can use for setting a shared buffer size. Again, this is just only giving you setting to start with a better performance of the Postgres, and based on the workload, you can further tune the shared buffers. There is another parameter called work mem, which is very, very important for sorting, for executing a query. Based on the workload, again, you can increase the work mem, reduce the work mem. This is like a dynamic parameter. You can actually set this parameter at the session level, at the user level. Again, like for example, if your application is executing heavy queries, right, and you are using a specific user or specific sessions, for those sessions, you can increase the work mem. This way, the query doesn't have to spill a lot of data on a disk, and it can utilize more memory for the operations and can give you better performance. But let's say if you have a OLTP workload, right, in general workload, for those sessions, you can reduce the work mem, right? But in general, if you want to start your system with a PostgreSQL, we recommend to go with total RAM minus shared buffers divided by 16 times of CPU cores. This is just only a parameter, a value which you can start with, and later on you can reduce, increase, tweak the work mem based on the workload. The other important parameter is maintenance work mem. Maintenance work mem is another work mem which get utilized by the PostgreSQL for certain operations like vacuum, reindexing, alter table command, create table command, or create table or CTAS operation like create table as select operation. Maintenance work mem is very, very important for these kind of activities. And we generally recommend to start with 15% of the total RAM minus shared buffer divided by auto vacuum max workers, and you can go up to 1 gigabyte, which is a good start. Just to keep just a specific tip which I would like to give it to you. If you are running a vacuum operation manually or auto vacuum processes, vacuum operation never takes more than 1 gigabyte of the maintenance work mem. So even though your maintenance work mem is set to 4 gigabyte, vacuum operation will take only 1 gigabyte of memory. But operations like alter table, create table as select, all those operations can utilize more maintenance work mem. So when you're setting these parameter, make sure that depending on how much maintenance operation you want to perform on a system, you can set this parameter. Again, this parameter is more like a dynamic parameter. You can set into the session level, or you can set it at the user level. So let's say if you are using a specific user for this maintenance operation, for those users, you can set this parameter to the higher value. Again, I'm sure you will be performing the maintenance operation during the off-peak hours. So you will have more memory available. And during that time, at a session level, you can set this value higher and execute your maintenance operations. And this way you can again improve the performance of the maintenance operation of the PostgreSQL. The other parameters for PostgreSQL tuning is auto vacuum work, ma'am. When you set the value to -1, it by default uses the value, whatever value you have set for the maintenance work, ma'am. Um, we generally don't recommend to set this value right away because if you have set the maintenance or if you have already tuned the maintenance work, ma'am, auto vacuum workers will utilize that value for the maintenance operation, like vacuum, analyze of the table, or if they find if they have to really vacuum the table, they can use this much of the memory for that operation. The other important parameter is called effective IO concurrency. And again, this we generally is very, very important parameter because it gives the hint to the system that what kind of IO operation it can perform or it can use. The IO bandwidth is allocated to the PostgreSQL for the IO operation. So that's why we always recommend this parameter to set correctly based on the read which you're using for the SSD or read based on the disk which you're using it. If you have a SSD disk allocated to the system, to the PostgreSQL for data directory and the wall file, we recommend to go with the IO effective IO accuracy to 200. This is again a start with the value because with the 200 value, we had seen better performance than the default value which you will find with the PostgreSQL. The other tunings are based on the wall tuning. This wall tuning is also very, very important because this is the important operation which you will see with the PostgreSQL because right ahead log where PostgreSQL maintains the transaction information tails, right? It needs to be optimized correctly to get a better throughput out of it. So first is called wall compression, right? Wall compression helps in reducing the IO operation, right? Because when your wall compression activity happens, the less IO activity happens on the system. And we always recommend to set this wall compression value to on based on the workload. It mostly works very well with the OLTP and OLAP workload. Other important parameters called wall log hence. It actually increase the IO operation a little bit, but it's very, very useful for certain activities like PG rewind operation. Let's say if you have a replica which got promoted and you want to make your old primary as a replica of the new primary, then PG rewind would help you in that direction, right? And it also helps you to recover certain states or to take the PostgreSQL data directly to a certain state through PG rewind. So that's a wall log hence is very important if you're really looking for maintaining the high availability and also want to reduce the time on making the old primary as a standby of the new primary. The other important parameter is called wall buffers. We always recommend to start with 64 megabytes. If you go less with this value, there'll be more IO activity on the system. 16 megabytes, people go with it, which is default, which is equals to the one the one wall size, which is the default wall size value. But we recommend to go with the 64 megabytes because for the OLTP workload, we had seen better performance with 64 megabytes over 16 megabytes. With 64 megabytes, we had seen performance of 5 times in certain like OLTP workload, like especially for the PG bench or TPCC kind of a workload. For OLAP, we had seen optimal performance with the 64 megabytes. So we always recommend to start with 64 megabytes for wall buffers. These are other parameter called checkpoint completion target. This parameter is really useful because this helps in determine the fraction of time between the two checkpoints, right? 0.5, which was before version 14, as it was a default value, and we used to recommend to go with the 0.9. But if you're using a version 14 or later, then I think you don't have to worry about this completion target value because by default it sets to 0.9. But if you're using a version 13, version 12, version 11 of PostgreSQL, we recommend you to change this value to 0.9. Other parameter is called checkpoint timeout. And again, it's a maximum time between the checkpoints. And again, this is very important because if you have a remember checkpoint is a very expensive operation, and which actually impacts the performance of the Postgres. So if you reduce the checkpoint, but if you keep a huge gap of the checkpoint, it is also not good for the PostgreSQL, because when you're going to perform a recovery, the recovery process will be very slow, and that will definitely impact the RTO requirement of your PostgreSQL, right? So we always recommend to go with the optimal value, like 15 minutes. I think 15 minutes gives you enough time for the recovery also, and also gives you a better performance. But in case checkpoint timeout is not happening on a system and checkpoint is happening too frequently, you will be able to look at the log file to find out whether the value which you have set for the checkpoint timeout is optimal value or not. And based on that, you can tweak it further based on your workload. The other important parameter is called max wall size. Again, max wall size determines when the checkpoint should happen based on the size of the wall file in the PG wall directory. If you have set the wall size, let's say 2 gigabytes, but your workload is really generating the 2 gigabytes of wall file within a few seconds, then checkpoint would be happening so often that it will impact the performance of the Postgres. So it's always or highly recommended that you tweak this parameter based on the workload. Keep the higher size, a good enough size, so that checkpoint should happen based on the checkpoint timeout instead of based on the size of the wall file in the PG wall directory. Let's look at the other query tuning parameters. These are some important parameters. Again, these are the cost, which really affects or helps in determining the right plan for the query execution. Like sequential page cost is very well known. In most of the success system 1.0, which is set and it's optimal, because we always recommend sometime like SSD kind of a disk, or if you have a rate defined correctly, or if you are reading a rate directly from the memory, sequential page cost makes more sense. Random page cost, if you are reading randomly from a disk, right? And random page cost also helps in determining whether you would like to read the data using the index scan or not. We always recommend to go with the lower value if your fastest disks are located to the Postgres. Generally 1.1, or maybe in certain cases, you can make it equals to sequential page cost. CPU tuple cost is the another hint to the optimizer. CPU tuple cost actually determine the processing cost of a tuple based on the query, right? By default, the value is 0.01, which is very low. Based on our benchmark, which we found that 0.03 is the optimal value, and we always recommend to start with the 0.03 for CPU tuple cost. Effective cache size is the another parameter, which is again kind of a hint to the optimizer. It's just only telling the optimizer that how much cache is available for the PostgreSQL, or how much data is cache. So we always recommend to go with the 52% to 75% of the available RAM. In some cases, you can, based on your workload, you can see you may have a some less cache, less than 50 to 75%, but you can find the exact value using the free command, which is available on the operating system. Based on the free command, you can define the value of the effective cache size. Other important parameters, these parameters is very useful to optimize the connections and the sessions on the PostgreSQL level, because if you have more idle connections or idle in transaction connections, those connections also impacts this performance of the system, impacts on the performance of the system. Like these connections always keep using the CPU cycles, and we hold on some CPU cycles because they sends the keep alive messages to the Postgres, and also hold some CPUs, or so that's why we always recommend to create some session timeout parameters, which actually helps you to release these processes and make it available, or release the CPUs also and make it available for the new processes or new requests coming from the users and the application. Again, you can set this parameter based on your application behavior. If your application requires is running a huge transaction or requires some idle connections, you can set that. But let's say if you want to use few connections and these connections are managed by the PG bouncer kind of a connection pooler, you can set this idle transaction session timeout at the PG bouncer level too. Again, it all depends on the workload, how long you're running a transaction, how big is the transaction. Based on those behavior, you can set this parameter. There is one more important parameter called shared preload library. We always recommend to be mindful, and be meaningful, be mindful on what are the important uh, libraries you want to load using the shared preload libraries. Like pgstat statement is very important tool or extension available with the Postgres. You can use this important library to trace the slow queries to find out the execution plan, how many times um, um, the queries are executing, and using the specific shared buffer or blocks which are already shared into the memory, right? It's very useful for monitoring and tuning the queries. So I would always recommend to go with the pgstat statement. But remember, when you load any specific library on the shared preload libraries, it actually impacts the performance of the system, which may be negligible, again, depending on how often you're using these shared preload libraries. There are other parameters like auto vacuum parameters, right? Because auto vacuum is very important for the sanity of the system, or also optimizing the system. These are the workers which ensure that system is not heavily bloated. System is highly optimized, performing the vacuum operation. Your stats up to date based on the workload, based on the transaction happening on the system. So log auto vacuum min duration, we recommend to set to 0. This would give the visibility around the performance of the auto vacuum of a system. Because whenever auto vacuum is going to kick in, the information get logged into the log file. You can look at the information and decide if you need to add more auto vacuum workers, or if you want to tweak or tune the auto vacuum work MAM, or if you want to tweak the auto vacuum cost limit to reduce the IO spikes on the systems. Same for the auto vacuum cost limit. We always recommend to start with 3000. There are other parameters, which is mainly for reporting and logging. Log time file size or log time files, it would help you to find out how many times your queries or sessions are using the temporary files on the system. If the queries are using the temporary files often, it means your queries are not performing well. You would like to tweak the workman parameters based on the pattern you will see with the log time file size. Log checkpoints helps you to determine how the checkpoints performing on a system. And based on this information, you can further tweak the parameter of the checkpoints, as we discussed in the previous slides. Log checkpoints, we always recommend to set it on because it gives you visibility around the performance of checkpoints. And there are other parameters like time statistics. This is very specific to the EDB Postgres advanced server, helps you to get the performance snapshots of the system by using a data. We recommend you to set it on if you're using the EPAS. Now, based on those processor parameters, you will definitely get a better performance out of the Postgres. So as you can see, we have covered the system, then we covered the operating system parameters, we covered the PostgreSQL parameters. Now there is a other thing which you need to keep in mind. How would you like to tune your PostgreSQL based on the workload, right? That is, how would you find out those slow running queries? There are some important tools and capabilities available in the PostgreSQL. Like there is a one view called pgstat activity, which is more like which helps you to monitor the sessions of the PostgreSQL. It will also help you to identify the slow running queries, long running queries, or queries which are in transition mode for longer period. You can use this particular view to identify those important sessions or sessions which are running or which are idle state, hasn't been timed out, and help you to tweak and tune those parameters. There's another parameter called log min duration statement. If you set this parameter to, let's say, 1000, which is a millisecond, which is 1 second, any query which is taking more than 1 milliseconds will automatically get logged into the PostgreSQL log file. And later on, you can look at the log file find out those. You can find out those slow running queries. You can look at the explain plan of those queries, and based on those information, you can tune the query or maybe change the query where clause to make it more performant. The other important extension which I mentioned is pgstat statements. We recommend to put that into shared preload libraries because this will help you to track and find out slow running queries. There is another tool called pgbadger. Pgbadger is a tool which helps you to analyze the log file, and it also helps you to give the visibility around how the system is performing over the period by looking at the log files. Very important tool, you can use that. We also have one more tool called auto explain. Auto explain helps you to log the query with the explain plan used by the query. It's very dynamic in nature. So let's say if you want to identify queries which are running more than 5 seconds, and you also want to look at the real-time plan of those queries, you can use auto explain. Auto explain module automatically log the slow running queries plus the plan used by the queries. With this, EDB Advanced Server comes with the other extensions like SQL Profiler. SQL Profiler helps you to capture the slow running queries for a specific between the specific duration. You can look at the queries plus the plan plus other information like how much IOPS was used by the query using the SQL Profiler. We also have the tool called Postgres Enterprise Manager. This tool also gives you the more visibility, gives you visibility around how the PostgreSQL performing, how sessions are performing with the PostgreSQL, what are the slow running queries, what are the events occurring on the system. But this tool also comes with some specific features like Postgres Experts or Tuning Wizard, which helps you to tune the system based on the workload or maybe optimize the system initially when you go into the production. We also have one more important tool called Index Advisor, which actually advises you around indexes based on the query patterns on the system. With those tools, there are some important recommendations when you're writing the queries, right? That is how you should write the queries. Like for example, this is one example you can see it here, where you can see the query in which condition the indexes will be used. Like for example, the first expression may not be useful and may not be useful for using the indexes, right? Because it will prevent the indexes. Here you can see the columns plus interval value will be dynamically evaluated first before rechecking the conditions. So we always recommend to really rewrite such kind of queries with the naked columns. Use naked columns with the where clause, right? This way you can make PostgreSQL to use indexes for your specific queries. The other some tips for rewriting queries, we always recommend to use not in. We don't recommend to use not in select. Instead of that, you can use exist clause, which are very performant. Or maybe converting not in with a join clause, that would be more optimal for your queries to get a better performance. In the same way, if you want to use distincts, right? Imprecise distinct, maybe you can use group by instead of distinct clause. Again, you have to look at exactly how you can leverage group by over distinct, right? Which is least complex and can give you better performance by using the hash base aggregation and selecting the informations, right? In certain cases, you would like to convert a huge queries into the common table expressions. Again, the common table expression was introduced in PostgreSQL 12. This way, you can again optimize your workload or queries to get a better performance out of the PostgreSQL. To get a better visibility of the query, what kind of a plan it's executing, you can use explain. Again, this is the best friend for a DBAs. They can find out the slow running queries based on tips shared in the few slides like log duration statement, also auto explain, or you can use other extension like pgstat statements. After identifying those queries, you can use this tool called explain to really look at the plan used by the query. And based on those information, you can tweak the query so that it can perform better with the PostgreSQL. Or you can actually execute analyze command in case the statistics are not up to date on the system. With this, you can also use explain and analyze command. Explain analyze command actually executes the query and also shows you the what plan it has used to execute the query. We always recommend to use begin rollback block when you are using the explain analyze to determine or to really finding out exactly what about finding out the plan used by the queries or finding out issues related to the plans using the explain command. There are other tools like pgadmin4, which also allows you to execute the explain plan. It gives you a nice GUI through which you can look at exactly how the plan will look like. In the PG admin 4, there is also analysis option available through which you can look at the indexes, you can look at the time, and you can do further analysis based on these estimations, whether the query is executing the right plan or not, or if the statistics of the system is up to date or not, or if you have to change these specific clauses to make it more performant, or make sure that it's using the less cost. These are also, again, one more UI of the explain. Again, it's a GUI interface of the explain available in the pgadmin 4. Again, explain plan helps you to eliminate bad estimations. If you're looking for, if you're seeing any kind of external source, hash batches, or heap fetches, right? Or if you're seeing lossy bitmap scans or wrong plan shapes, right? You can look at these information using this explain command, and accordingly you can change your where conditions, quell states, plus you can look at the stats too, right, and choose the optimal plan or rewrite the queries based on the tips which was shared in the previous slides to make it more performant. There's another important, I would say, feature available in the Postgres called partition, right? I'm just going to cover that quickly. There are different partitioning capabilities available in the PostgreSQL. This partition scheme, when I'm saying capabilities, a partition scheme available, like you can partition a huge table using hash partition, list partition, range partition, depending on whatever scheme you want to use it based on a use case. But partition helps in multiple operations like maintenance operation. And let's suppose if you have a huge table, for a huge table, if you use a partition table, your query may perform better based on the what are the important where conditions you're using it. And in EDB Advanced, we have automatic partition too, which is called interval partition, and you can leverage that automatic partition based on the workload or based on the data which you're storing on a system, right? So at the end, I will just conclude, and I will say that with PostgreSQL, you can really get a better performance by looking at the hardware, by looking at the operating system, the important parameters which I mentioned in this session. You can look at those. There are important tools available for you, like pgadmin, PAM, pgbadger, extensions available with the PostgreSQL to identify those slow-running queries or something which is not performing well. You can enable those logging parameters, look at those operations, and tune your system to perform better, right? So that's all about the PostgreSQL and tuning capabilities.
Thank you so much, Vibhor. Thank you for the presentation. Okay, we actually have very limited time left, but I still want to finish maybe with 2-3 questions quickly.
Mm-hmm.
So the first question, does EDB provide tools for the initial configuration of PostgreSQL?
Yes, we do provide tools, and we also provide Ansible module for the initial configuration of Postgres. If you're using a Postgres Enterprise Manager, a tool from the Enterprise DB, which is a solution from the Enterprise DB, it comes with the 3 important capabilities. One is called Postgres Expert, which helps you to look at the important parameters and gives you certain recommendations. And second is the SQL profiler, which helps you to trace the slow running queries, can help you to tune the system. And the index advisor will guide you exactly what are the indexes you would need for your SQL queries on the tables.
Thank you, Vibhor. And the second question is, how would you tune Workman for PostgreSQL?
Well, that's a fantastic question, which you have asked. So Workman, as I mentioned, that is very, very important for certain operation of the queries, right? If you have a proper Workman parameter set, proper Workman value set for the query, your query will perform better. To tune this Workman parameter, I always recommend to set long underscore temp underscore size parameter, or long underscore temp underscore file size parameter in the PostgreSQL. With this parameter, you will be able to see how many times the query is for creating these temp files on the disk. And based on this set size, you will be able to generate a pattern. And based on those patterns, you may be able to set this Workman parameter optimally for your workload.
Thank you. I will run with the last question, then we will wrap up. So what is the limit of maintenance Workman for vacuum operation?
Good question, and I think I covered that also. For vacuum operation, PostgreSQL mostly use up to 1 GB of the maintenance Workman. But it doesn't mean that when you set the maintenance Workman to 4 GB, it will never be get used. It might get used by the other operations like alter table or CTAS table or CTAS create table as command, right? Or if you're doing a reindexing, in those operations, maybe the maintenance Workman will be used if you have set maintenance Workman more than 1 GB.
Thank you so much, Vibhor. Yeah, if you have any questions or you want EDB to follow up with how EDB can support you on your Postgres optimization, please feel free to drop us an email. Thank you very much for attending today's webinar. Thank you. Bye.
Thank you. Bye.